All right, now we're just going to continue along with some more conversion factors that are important to stoichiometry. So far, the ones that you know are Avogadro, microscopic to macroscopic. You know about what a chemical formula really means, what those subscripts mean, and how that relates to the whole. You also know about the molar mass, how that can get from mass to moles and moles to mass of different molecules and atoms and things like that. Now we need to know, what does a balanced chemical equation really mean? And just in case I don't make this explicit, I almost always will abbreviate balanced chemical equation as the BCE, the balanced chemical equation. So let's give you a chemical equation. I think I use that one later. Here's one of my favorite ones. Yep. Aluminum reacts with hydrochloric acid to yield aluminum chloride and hydrogen gas. So that's a balanced chemical, well, no, that's not balanced. Oh my goodness. That is a skeletal equation. Aluminum reacts with hydrochloric acid to yield aluminum chloride and hydrogen gas. Now we have to balance it. Aluminum to aluminum, chlorine to chlorine, we would need a coefficient of 3. Oh, but that's problematic because now we have 3 hydrogens in our reactants and we can only have an even number of hydrogens in our products. So what that means is that this has to go up to 6. That means this needs a 2, this needs a 3, and that needs a 2. Okay, so that's our balanced chemical equation. And what those coefficients mean on the microscopic level, it means 2 atoms of aluminum reacts with 6 molecules of hydrochloric acid to yield 2 units of aluminum chloride and 3 molecules of hydrogen gas. Microscopic. But again, if we scale everything with Avogadro's number, they become the number of moles. So there are conversion factors galore here. What this means is that 2 moles of aluminum reacts with 6 moles of hydrochloric acid. So we can go reactant to reactant. We can say that 2 moles of aluminum forms 2 moles of aluminum chloride. You can go reactant to product. You can say 3 moles of hydrogen are formed from 6 moles of hydrochloric acid. Product to reactant. Okay, so all of these innocent looking coefficients tell you microscopically the number of atoms and molecules and units to each other, and macroscopically how many moles of each. So let's get right into a stoichiometric example of what I'm talking about. So again, if I were to do this in class with you, I would give you time to work this out. I recommend that you pause the video and try to work it out before you watch me solve it. But magnesium reacts with hydrochloric acid to yield magnesium chloride and hydrogen gas. So that's our chemical equation that we're going to need to translate from words into symbols and then balance it. And then the question is asking, how many grams of hydrochloric acid are needed to react with 2.56 grams of magnesium? All right, so magnesium reacts with hydrochloric acid to yield magnesium chloride and hydrogen gas. Remember, the hydrogen gas is a diatomic molecule. Now we have to balance it. This is straightforward. We just need a coefficient of 2 in front of the hydrochloric acid. Now that is a balanced chemical equation. So all of those coefficients are ratios to each other. Now let's try to figure out exactly what we're doing. We're trying to go from 2.56 grams of magnesium, and we're going to convert that into grams of hydrochloric acid. Okay, so we're going from grams of magnesium to grams of hydrochloric acid. There is no way to get there in one step. We have two different compounds. One compound is magnesium, one compound is hydrochloric acid. The only way you can get between two different compounds is through the moles, and then the only way you can get the mole ratio is from the balanced chemical equation. You cannot get from one kind of compound to another kind of compound unless you go through moles and the balanced chemical equation. So rather than, we can't do this in one trip, we have to take a pit stop, we have to take a layover somewhere else. We're going to go from grams of magnesium into moles of magnesium. That's going to use the molar mass of magnesium. We're going to go from moles of magnesium to moles of hydrochloric acid. That's going to use the balanced chemical equation to get those ratios. And then we're going to go from moles of hydrochloric acid into grams of hydrochloric acid using the molar mass of hydrochloric acid. So that's our route that we're going to take, and each arrow is its own conversion factor. So we're going to start our dimensional analysis, 2.56 grams of magnesium. The periodic table tells us that there's 24.31 grams of magnesium in every 1 mole of magnesium. Please, for the love of all things, don't forget your unit and your label. You're going to start to get super confused if you don't label things. So this is the molar mass of magnesium. Then the balanced chemical equation tells us that 1 mole of magnesium reacts with 2 moles of hydrochloric acid. Those are the coefficients from the balanced chemical equation. 1 mole of magnesium reacts with 2 moles of hydrochloric acid. And then last but not least, we're going to use the molar mass of hydrochloric acid. 1 mole of hydrochloric acid weighs 1.01 plus 36.46 grams. Again, that's the molar mass of hydrochloric acid. So now, 2.56 times 2 times 36.46 divided by 24.31 gives us 7.68 grams of hydrochloric acid. And that's great. This is what the power of this is. If you know that you want to completely consume, you want to completely use up all 2.56 grams of magnesium, then you know you need 7.68 grams of hydrochloric acid. You can go and weigh these things out. So when you do the reaction in the lab, you know exactly the different amounts that you're using so that you can know how much to use. I mean, it's important that you know exactly how much to use. All right, here again, if we were doing this in class, I would give you this as an example. So again, I highly, highly, highly recommend you pause the video here and try this on your own before you keep going, because this is crucial. So pause here. Calcium phosphate, chemical formula Ca3PO42, reacts with sodium chloride, NaCl, to yield calcium chloride, CaCl2, and sodium phosphate, Na3PO4. That's the skeletal equation. Now we have to balance it. We're going to need a coefficient of 3. Then we're going to need a coefficient of 6, a coefficient of 2. Now we're balanced. 3 calciums, 2 phosphoruses, 8 oxygens, 3 calcium, 6 chlorines, 6 sodiums. How many grams of phosphate are formed from 30 grams of calcium phosphate? sodium phosphate. Once again, two different compounds. Calcium phosphate is different than sodium phosphate. Whenever you have two different compounds, the only way you can go between them is through their number of moles from the balanced chemical equation. So first off, molar mass will get you to moles of calcium phosphate. Then the balanced chemical equation tells you the ratio. 1 calcium phosphate forms 2 moles of sodium phosphate. And then finally, the molar mass of sodium phosphate gets you from moles to grams. All right, so let's have at it. We have 30 grams of calcium phosphate. Now the molar mass, and again, I'm doing this on the fly, so you guys will hear me calculate things. We have 3 calciums, so that's 3 times 40.08. No, that is not an 8. 3 times 40.08 plus 2 phosphorus, 2 times 30.97 plus 8 times 16. That gives us a molar mass of 310.18. Again, I cannot emphasize this enough. The units on that are grams per mole when we're talking macroscopic. That means there's 310.18 grams of calcium phosphate in every 1 mole of calcium phosphates. Like I said before, you guys like to fight me on using density as an algebra thing, and it can lead you astray. You absolutely cannot do that here. Use it as a conversion factor. So there's 310.18 grams of calcium phosphate in every 1 mole of calcium phosphate. Now, the balanced chemical equation tells us every 1 mole of calcium phosphate reacts to form 2 moles of sodium phosphate. Every 1 mole of calcium phosphate reacts to form 2 moles of sodium phosphate. And last but certainly not least, 1 mole of sodium phosphate. And we have to figure out how many grams that is. You go from grams to moles by the molar mass. So let's figure out the molar mass. We have 3 sodiums, so that's 3 times 22.99, plus 1 phosphorus, 30.97, plus 4 oxygens, 4 times 16, 163.94. So that's 163.94 grams per mole. Every 1 mole of sodium phosphate weighs 163.94 grams. Double check, make sure everything cancels. Both the unit and the label, grams of calcium phosphate, moles of calcium phosphate, moles of sodium phosphate. You're left with grams of sodium phosphate, which is what you want. 30 times 2 times 163.94 divided by 310.18, 31.7 grams of sodium phosphate. All right. I'm going to stop the video here and make 1 more. I think maybe 2 more. If there are any questions, let me know. And remember, this isn't the full extent of stoichiometric questions I can ask you. If any of these compounds are liquids, I can start to ask you things about their density and so on. So this is the most straightforward full stoichiometric question, but I can always get more complicated. And so it's really important that you understand each one of these conversion factors. All right, hope that helps.